All right, so 1-1 to 1-5, your test review. Again, we're going very quick, so I'm just going to go right through, like I said, all of these. For examples 1 through 3, you're determining whether the lines are parallel, perpendicular, or neither. Remember, if they're parallel, you have the same slope, same exact slope. Perpendicular, your slopes are opposite reciprocals, and then neither would be two different slopes. No correlation with them whatsoever. So for example 1, you have 5x minus 3y is equal to 6. We're going to solve that for y to put it in slope-intercept form to find our slope. So we're going to just subtract the 5x from each side. We get negative 3y is equal to negative 5x plus 6. We divide each side by the negative 3. And you get that y is equal to 5 over 3x minus 2. So your slope for this one is 5/3. For the 3x plus 5y is equal to 2. We're going to subtract the 3x from each side to solve for y. So we have 5y is equal to negative 3x plus 2. We divide each side by the 5. And you have that y is equal to negative 3/5 x plus 2. So for this one, your slope is negative 3/5. If you compare your two slopes, they are opposite reciprocals. 5/3 and negative 3/5, opposite reciprocals. So these two are perpendicular. You can use the symbol for perpendicular if you'd like to. Totally up to you. For number 2, it gives you 2x minus 4y is equal to 3, and 2x plus 4y is equal to negative 3. So we're going to do the first one, 2x minus 4y is equal to 3. And we're going to solve that for y. So we're going to subtract the 2x from each side. That gives us negative 4y is equal to negative 2x plus 3. And then we divide each side by the negative 4. So we have y is equal to 1/2 x minus 3/4. So your slope for this one is just 1/2. For the 2x plus 4y is equal to negative 3. We're going to subtract the 2x from each side. We have 4y is equal to negative 2x minus 3. And we just divide each side by the 4. So we have that y is equal to negative 1/2 x minus 3/4. Your slope for this one is negative 1/2. So these are not opposite reciprocals. They are opposites, but not reciprocals. So they're not perpendicular. And then they're not the exact same because they're different signs. So they're not parallel either. So this is just neither. For number 3, we have 3x plus 4y is equal to 8. And negative 12x minus 9y is equal to 27. If I work with the one on the left or the one on the top first, I'm going to subtract 3x from each side. This gives us 4y is equal to negative 3x plus 8. Then we divide each side by the 4. So we have y is equal to negative 3/4 x plus 2. For the other one, we're going to add 12x to both sides. So we have negative 9y is equal to 12x plus 27. Then we divide by negative 9 on both sides. So this gives us y is equal to negative 4/3 x minus 3. The two slopes that we have are negative 3/4 and negative 4/3. So these are reciprocals of one another, but not opposites. So because that is the case, then these are neither as well. Oops. For the next part of your review, it asks you to solve by completing the square. So remember when you're doing these, if you would like to complete the square to solve, move your c term over so that way your a and your b term, that x squared and that x are on the same side. Make sure your a is 1. Get your b, divide it by 2, square it, add it to both sides, factor the left, add the right, then solve for x. Okay, so for number 4, we have f of x is equal to x squared plus 8x plus 7. We can rewrite this as 0 is equal to the x squared plus 8x plus 7, and then move the 7 over. To move the 7 over, we would subtract it from each side. So this just gives us x squared plus 8x is equal to negative 7. From here, you just get your b term, which is that 8 divided by 2. So b over 2 squared. That's going to give you 8 over 2 squared, which is 4 squared. That is 16. The 16 you're going to add to each side of your equation. So you're going to have x squared plus 8x plus 16 is equal to negative 7 plus 16. You're going to factor the left side, add your right side. To factor the left side, it is a perfect square trinomial, so take what you had in the parentheses that you squared and put it in with x. So it was a 4 squared, so it's going to be x plus 4 squared is equal to negative 7 plus 16 gives us 9. You're going to take the square root of both sides from here. That's going to cancel out the power to give you x plus 4 on the left side. And then the square root of 9 is plus or minus 3. Subtract your 4 from each side. Remember, with this, you have x is negative 4 plus 3, and x is negative 4 minus 3. So your answers for this are going to be negative 1 and negative 7. For number 5, you have x squared minus 12x minus 10 is equal to 0. Move your 10 over, add it to both sides. This is going to give us x squared minus 12x is equal to 10. Your b in this case is negative 12. So if we do b over 2 squared, we're going to have negative 12 over 2 squared, which is negative 6 squared, and that is 36. We're going to add this 36 to both sides of our equation to give us x squared minus 12x plus 36 is equal to 10 plus 36. From here, we're going to factor the left side, add the right side. In the parentheses that we squared, we had a negative 6. So this factors out to be x minus 6 squared is equal to 10 plus 36 gives us 46. When we find the square root of both sides, it's going to cancel out the squared. So this is going to give us x minus 6 on that left side. And then the square root of 46, it's not a perfect square. You can't simplify it because it only has 2 and 23, and 23 is a prime number. So this is going to be plus or minus the square root of 46. From here, you're going to add the 6 to both sides. So it's going to give you an answer of x is equal to 6 plus or minus the square root of 46. For 6, we have negative 3x squared plus 18x minus 30 is equal to 0. To first solve this by completing the square, you have to get x squared to have a 1 as a coefficient. So you're going to have to divide everything by that negative 3. It goes out front to give you negative 3 times x squared minus 6x plus 10 is equal to 0. If you were to separate this and do, negative 3 is equal to 0, x squared minus 6x plus 10 is equal to 0, that negative 3 is equal to 0 is going to cancel out. So don't even work with it. Unless it has a variable with it, don't bother with it. Okay? So from here, just use the x squared minus 6x plus 10 is equal to 0. Move your 10 over, subtract it from each side. So this is going to give you x squared minus 6x is equal to negative 10. Your b is negative 6. So b over 2 squared is going to give you negative 6 over 2 squared, which is negative 3 squared. And that's 9. Add your 9 to both sides of your equation. So you have x squared minus 6x plus 9 is equal to negative 10 plus 9. In 1.5, we went over, when you take the square root of a negative, it becomes an I, right? So keep that in mind when you do this. Factor the left side, add your right side. You have x minus 3 squared is equal to negative 1. Take the square root of both sides. You have a negative underneath the radical on that negative 1. So it just becomes x minus 3 is equal to plus or minus I. Move the 3 over, add it to both sides. This is going to give you a final answer of x is equal to 3 plus or minus I. For the next part in your review, you're determining the number and the types of solutions using the discriminant. Your discriminant is b squared minus 4 times a times c. When you do these, make sure everything is on the same side as make sure everything's on the same side of the equal sign and your equation's equal to 0. Once you do that, identify your a, your b, and your c, plug them in, simplify. If you get that something is greater than 0, you're going to have 2 real solutions. Something is equal to 0, so 0 is equal to 0, it's 1 real solution. And then a negative number is less than 0, it's 2 imaginary solutions. So if we look at example 7, you have x squared minus 6x is equal to 10. You're going to move the 10 over, subtract it from each side. That gives you x squared minus 6x minus 10 is equal to 0. Your a is 1, b is negative 6, c is negative 10. So doing this into your discriminant, b squared minus 4 times a times c, that's going to give you negative 6 squared minus 4 times 1 times negative 10. The negative 6 squared is 36. Negative 4 times 1 times negative 10 is a positive 40. 36 plus 40 is 76. 76 is greater than 0. So that's 2 real solutions. B squared minus 4 times a times c. Because your discriminant gives you an answer that's greater than 0. If your answer is greater than 0, it's 2 real solutions. If it's equal to 0, it's 1 real solution. If it's less than 0, it's 2 imaginary solutions. For number 8, you have 3x squared plus 2x plus 7 is equal to 0. All of your terms are on the same side of the equal sign. We're good. Identify your a, your b, and your c. Your a is 3, b is 2, c is 7. Use your discriminant, b squared minus 4 times a times c. Plug these all in. So we're going to have 2 squared minus 4 times 3 times 7. The 2 squared is 4. Negative 4 times 3 is negative 12. Times 7 is negative 84. 4 minus 84 is negative 80. Negative 80 is less than 0. So we have 2 imaginary solutions. For number 9, you have negative 2x squared minus 14 is equal to 8x. We're going to move the 8x over by subtracting it from each side. So it gives us negative 2x squared minus 8x minus 14 is equal to 0. Our a is negative 2, b is negative 8, c is negative 14. So use your discriminant that b squared minus 4 times a times c and plug it in. It's going to give you negative 8 squared minus 4 times negative 2 times negative 14. The negative 8 squared is 64. The negative 4 times negative 2 is 8. 8 times negative 14, the 8 and the 4 is 32. 8 and 1 plus 3 is 11, so that's 112. If we do 64 minus 112 off the top of my head, I don't know what it is, but it's going to be a negative number. A negative number is less than 0, so we have 2 imaginary.
On the test, like let's say like we're gonna know it's negative, do you still want us to write like that number?
No, I don't care. For number 10, you have 10x minus 5 is equal to 5x squared. I'm going to move the 10x over by subtracting it from each side. I'm also going to move the 5 over by adding it to each side. So this is going to give us 5x squared minus 10x plus 5 is equal to 0. A is 5, b is negative 10, c is 5. So your discriminant is that b squared minus 4 times a times c. Plug everything in. It's going to give us negative 10 squared minus 4 times 5 times 5. 10 squared is 100. The negative 4 times 5 is negative 20 times 5 is negative 100. 100 minus 100 is 0. and 0 is equal to 0. So that's one real solution.
If you were to just
For your next part, you're using your quadratic formula in order to solve. For 11 and 12, I'm not going to use the quadratic formula, but the other ones I will, only because it's a lot easier to solve these not using the quadratic formula. So for 11, it gives you x squared plus 121 is equal to 0. Move your 121 over, subtract it from each side. You have x squared is equal to negative 121. From here, you would take the square root of both sides, and you do have that negative underneath. So when you take the square root of 121, you got to remember that negative. You got to remember you're taking the square root of both sides. So it's going to be plus or minus, and your answer is going to include an I. So you're going to have x is equal to plus or minus 11i. For number 12, you have 2x squared plus 200 is equal to 0. Again, if we move that 200 over, we would subtract it from each side. We have 2x squared is equal to negative 200. Then divide each side by the 2, and you have x squared is equal to negative 100. Take the square root of both sides. You have a negative underneath that radical, so x is equal to plus or minus 10i. Okay, so on the next page, for 13, you have 5x squared plus x minus 2 is equal to 0. To use your quadratic formula, that negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. What's your a, what's your b, what's your c?
A is 5, B is 1, C is -2.
Good. So again, your quadratic formula, negative b, the opposite of b, so that's going to be the opposite of 1, plus or minus the square root of b squared, that's 1 squared, minus 4 times a, which is 5, times c, which is negative 2, all over 2 times a, which is 5. The opposite of 1 is negative 1, plus or minus the square root of 1 squared is 1, negative 4 times 5 is negative 20, times negative 2 is positive 40, all over 2 times 5, which is 10. Simplify that radical. 1 plus 40 is 41, so x is equal to negative 1 plus or minus the square root of 41 all over 10. For number 14, you have negative x is equal to 1 plus 2x squared. Move that x over, add it to both sides. When you rewrite this, write it in standard form. So you're going to have 2x squared plus x plus 1 is equal to 0. Your a is 2, b is 1, and c is 1. Again, use your quadratic formula. So x is equal to the opposite of b, so that's the opposite of 1, plus or minus the square root of b squared, so 1 squared minus 4 times a, which is 2, times c, which is 1, all over 2 times a, so 2 times 2. The opposite of 1 is negative 1, plus or minus the square root of 1 squared is 1, negative 4 times 2 is negative 8, times 1 is negative 8. All over 2 times 2 is 4. This simplifies to be negative 1 plus or minus the square root of negative 7 all over 4. You cannot leave a negative under the denominator or under the radical. So you have to turn that into a positive and bring out an I. So this is going to give you an answer of negative 1 plus or minus I square root 7 all over 4. For 15, you have negative 4x squared plus 3x minus 7 is equal to 0. Your a is negative 4, b is 3, c is negative 7. So again, use your quadratic formula. X is equal to the opposite of b, so the opposite of 3, plus or minus the square root of b squared, so 3 squared, minus 4 times a, which is negative 4, times c, which is negative 7, all over 2 times a, which is negative 4. From here, you're going to have x is equal to negative 3, plus or minus the square root of 3 squared is 9. Negative 4 times negative 4 is 16, times negative 7. 7 times 6 is 42, 7 times 1 is 7 plus 4 is 11. Keep it negative. All over negative 8. From here, you're going to have negative 3 plus or minus the square root of 9 minus 12 is going to be a negative 103 all over negative 8. Again, you can't leave the negative underneath the radical, so take it out. It becomes x is equal to negative 3 plus or minus I square root 103 all over negative 8. The next part in your review goes over your imaginary and your real numbers. Remember, your real number part always has to go first in your answer when you are adding, subtracting, multiplying, and dividing these. With these, your real number part is the part that does not have an I attached to it. Your imaginary part is the part that has the I attached to it. So when you are adding, subtracting, multiplying, and dividing these, just be careful. Treat them like variables, kind of, for adding, subtracting, and multiplying. But when you're dividing, remember you can't have an I in the denominator in your answer. So for 16, you have 5 plus 6I minus, parentheses, 3 minus 7I. So you're going to distribute that negative into the second set of parentheses. So it's going to give us 5 plus 6I minus 3 plus 7I. Combine your like terms from here, starting with your real numbers. The 5 minus 3 gives us 2. The 6I plus 7I gives us 13I. So that's 2 plus 13I. For 17, you have negative 9 minus 5I minus 4 times 8I minus 3. Distribute the 4. So this is going to give you negative 9 minus 5I minus 32I plus 12. Again, you have like terms here, so combine them. Your real parts are the negative 9 and the 12, which combine to give us 3. And then your imaginary parts are the negative 5 and the negative 32I, which give us negative 37I. So 3 minus 37I. For 18, we have negative 6 times 8 plus 9I. So we're going to distribute the negative 6 in. This gives us negative 48 minus 54I. It's in A plus BI form, so that is your answer. For 19, we have 11 plus 3I minus 5I. For this one, you do not need to do anything with distributing a negative, so we're just going to get rid of those parentheses and combine like terms. Your like terms here are the 3I and the negative 5I, which give us 11 minus 2I. For 20, you have 8 minus 5I times 6 plus 4I. So we're going to FOIL this one. The 8 times 6 is 48I. Oh, no, sorry, just 48. The 8 times 4I is 32I. The negative 5I times 6 is negative 30I. And negative 5I times 4I is negative 20I squared. Your like terms are the 32I minus 30I. So those combine to give us 48 plus 2I. That I squared is negative 1. So that's negative 20 times negative 1. The negative 20 times negative 1 becomes a positive 20. So we have 48 plus 2I plus 20. You still have to combine like terms here. So 48 plus 20 gives us 68 plus 2I. For 21, you have negative 10 plus 7I times 3I minus 4. So again, we're going to FOIL this. So negative 10 times 3I is negative 30I. The negative 10 times negative 4 is a positive 40. The 7I times 3I is 21I squared. And then the 7I times negative 4 is negative 28I. Your like terms here are the negative 30I and the negative 28I. So that gives us 40 minus 58I plus 21I squared. So that's 21 times negative 1. From here, you're going to get 40 minus 58I minus 21. combine your like terms. The 40 minus 21 gives us 19 minus 58i. And then again, make sure that it's in a plus bi form. For 22, we have 3 minus I over 2 minus I. For this one, you need to get rid of the I in the denominator. So multiply the top and the bottom of this fraction by the conjugate of your denominator. So we're going to put parentheses around the top and the bottom, and then multiply it by 2 plus I for both. We're just going to FOIL this. So 3 times 2 is 6. 3 times I is 3i. Negative I times 2 is negative 2i. Negative I times I is negative I squared. This all goes over 2 times 2, which is 4. 2 times I is 2i. Negative 2 times I is negative 2i. And negative I times I is negative I squared. This then simplifies when you combine like terms to be 6 plus I minus negative 1 all over 4. Those two i's cancel since they're opposites, minus negative 1. The double negatives turn into positives. So 6 plus 1 gives us 7 plus I over 4 plus 1 is 5. For 23, we have 6 minus 3i all over 5 minus 2i. So again, we're going to put parentheses around the top and the bottom of this. Find the conjugate of your denominator, which is 5 plus 2i, and then multiply the top and the bottom by that conjugate. FOIL the top out. We have 6 times 5, which is 30. 6 times 2i is 12i. The negative 3 times 5 is negative 15i. And negative 3 times 2i, or 3i times 2i, is negative 6i squared. This goes over 5 times 5, which is 25. 5 times 2 is 10i. Negative 2 times 5 is negative 10i. And negative 2 times 2i is negative 4i squared. From here, we're going to simplify and combine like terms on the top and the bottom. So we're going to do 30 minus 3i minus 6 times negative 1, because I squared is negative 1, all over 25. Those 10 i's cancel because they're opposites, minus 4 times I squared, which is negative 1. This is going to then give us 30 minus 3i plus 6, all over 25 plus 4. So then this completely simplifies to be 36 minus 3i all over 29. For this one, because that 29 is not a factor of 3 or a multiple of 3, it stays the way that you see it. For your last two questions, they come from that 1.1 lesson. So you're finding your midpoint and your distance, and then parallel perpendicular lines. So for 24, you're given the points A and B. A is 2, 9. B is negative 1, negative 3. You're finding the distance and the midpoint between these two. For the distance, remember your distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. You need to know that for tomorrow. So to find your distance, I'm going to label A as x1, y1, B as x2, y2. To find the distance, it's going to be the square root of x2, so negative 1, minus x1, which is 2 squared, plus y2, which is negative 3, minus y1, which is 9 squared. This is going to give us the square root of negative 1 minus 2 is negative 3 squared, plus negative 3 minus 9 is negative 12 squared. The negative 3 squared is 9. The 12 squared, or negative 12 squared, is 144. So this gives us your distance is equal to the square root of 153. For your midpoint, it is that x1 plus x2 over 2, comma y1 plus y2 over 2. So just find the sum of your x values. That's 2 plus negative 1 all over 2, comma the sum of your your sum of your x values divided by 2, comma the sum of your y values. So that's 9 plus negative 3 all over 2. The 2 minus 1 gives us 1 over 2. The 3 away from this 9 is 6 over 2. So this just simplifies to give us a midpoint of 1/2, comma 3. And then for your last question, it tells you to find the equation of a line in slope-intercept form that passes through the point 5, negative 7, and is parallel and perpendicular to 6x minus 5y plus 1 is equal to 0. Solve this for y, put it in slope-intercept form to find your slope. Add the 5y to both sides. You have 5y is equal to 6x plus 1. Divide by the 5. So y is equal to 6 over 5x plus 1/5. The parallel slope is going to be 6 over 5. Your perpendicular slope is negative 5 over 6. To find the line in point slope form with the 5, negative 7, for the line that's parallel, you're going to have y minus, negative 7 is equal to 6 over 5 times x minus 5. Distribute. You simplify. Y plus 7 is equal to 6 over 5x minus 6. Move the 7 over, subtract it from each side. Your parallel line is y is equal to 6 over 5x minus 13. For the perpendicular line, your slope is negative 5/6. You're still using the 5, negative 7. So it's going to be y minus negative 7 is equal to negative 5 over 6 times x minus 5. Distribute. Simplify your double negatives. This is going to give us y plus 7 is equal to negative 5 over 6x plus 25 over 6. You can't simplify the 25 over 6, so just move the 5 over 6 or the 7 over. Subtract it from each side. Now think about this. You're subtracting fractions, so they need the same denominators. So you have 25 over 6. Turn the 7 over 1 into something over 6. That's going to be 42 over 6. So 42, 25, 2 turns into 12, 4 turns into 3, 12 minus 5 is 7, 3 minus 2 is 1. So that's y is equal to negative 5 over 6x minus 17 over 6. And that's the line that is perpendicular.